experiment on electricity. So we are going to be practicing year 2000. Okay, from past question. If you have your past question, year 2000. Okay, and I think year 2015 also will serve as a guide. Okay, so now this is the apparatus needed for this experiment. You need a resistor box. This is what we call a resistor box. We need a key. This is the standard resistor, 2 ohm standard resistor. This is the battery, 2 pairs of battery, and then we have what we call the ammeter. This is ammeter. Okay, and then we have the voltmeter. This is a voltmeter. We can use this to measure the EMF of the battery. Okay, so now we are going to be going by the instruction given from this manual, this past question and answer, year 2000. Okay, usually you'll be given a set of instruction. You are expected to follow the set of instruction, and again you'll be given a diagram to follow. Okay, the diagram will always serve as a guide on how you will connect your circuit. I already did the connection because to make the video as short as possible. Okay, so we have this is the diagram. This is the diagram. Okay, so from the diagram, okay, this is the diagram. My dear, come like this. This is the diagram. So it says, the first question says, measure and record the EMF of the accumulator provided. So we are not using accumulator, we are using 2 pairs of battery. So we are going to measure the EMF using the voltmeter. So we'll measure it. You will just connect it like this and then you measure. Okay, can you see? Please come to my back so that you can see. You can see the reading yourself. Can you see the reading? It's fluctuating because my hand is fluctuating. Can you read this?
Yes.
This is what?
2.9.
Very good. So we have 2.9. So record it now. You write E. You record E. Okay? You record E is equal to 2.90. You are going to record it in 2 decimal places. Okay? Remember the unit is in volts. So you are going to record 2.90 volts. 2 decimal places. Though we have 2.9, you will not write 2.9. You write what? 2.90 volts. Are you here? Yes. So now let's follow the next instruction. It says connect a circuit as shown in the diagram. This is the diagram. This is the diagram. Okay? And they say connect a circuit as shown in the diagram. S is a standard resistor. R is the resistance box. This is resistance box. With R is equal to 0, close the key. Read and record the ammeter reading. So we are going to connect the circuit as shown in the diagram. Okay? Okay, come like this. So this is what we have. This is the diagram given as the question. Okay, this is the diagram. Now look at this. This is the standard. Let's start with the standard resistor. This is the standard resistor. Here it is. This is the standard resistor. Okay, the next is the battery. So the battery will be connected here. Can you see? Then we have the ammeter. Okay, next is the ammeter. This is the ammeter. From the ammeter to the resistance box, this is the what? Resistance box. Look at it. Resistance box. From the resistance box to the key, this is the key. And then from the key to the standard resistor, from the key to the standard resistor, and that is the circuit. Okay, so now they are asking us to remove 0 ohms. We have to start from 0, then 1, 2, we keep increasing, and then we take the current reading on the ammeter. Okay, but if you look at this resistance box I'm having here, it is the minimum is 5. Okay, we have 5, 10, 20, 50, 100. Okay, so I'm going to be using what I have, but the first question we have 0, 1, 2, 3 ohms. So I will do with what we have. So we'll start with what? 0, 5 ohms, 10 ohms, and we have 15 ohms. I think it's 5 readings. Then we'll stop at 20. This is the reading we are going to be dealing with because of the kind of apparatus I have here. Okay, I don't have the one that can take 1, 2, 3. Okay, so we'll do this. We'll connect the circuit. 0 meaning I'm not going to remove anything from the resistance box. I'm not removing anything. So I will connect my circuit again and take the reading from the ammeter. We are going to be taking the reading from what? The ammeter. You can see we have 2 readings up and down. The reading we are going to be taking is going to be the one that is at the top, 0 to 3. Okay, the one down is for 0 to 5. So we are going to be taking the one for the up one. So we have to understand this reading so that when we are taking the reading, we will know what we are doing. Now look at this. This is the upper one. This from here to here is 0.6 ampere. Can you see? Yeah? So it means half of it will be what? 0.3. Do you understand?
Yes.
Do you understand?
Yes.
Half is going to be what? 0.3.
0.3.
Since the up one from here to here is 0.6, it means the half is going to be what? 0.3. That means divided by 2. Are you following? So now, how many division do we have from here to here? We have 5. So to get the reading for each of it, we are going to do 0.3 divided by 5. Punch your calculator and give us the value for each line. 0.3 divided by 5 will give us 4, so that we can get for each line. Do you understand? What do we have? Or we'll do 0.6 divided by 10 to get for each line. You see the same thing. Yeah, divided by 10. What do we have? So it means each division, each one line is 0.06. Do you understand? Are you following? So it means if this thing shows on 2, we'll do 0.06 times 2. If this indicator is on 3, the third line, we'll do 0.06 times what? 3 to get the what? The current reading on the what? Ammeter. Do you follow? So now let's connect the circuit to do that for what? 0. Let's connect it. And what do we have? We have 0.6. Are you here? So can you see it? We have 0.6. So we are going to record 0.6. Okay, let's just add 0 in front of it to make it 2 dps. Okay, so now the next thing now to do for 5, you remove the key on 5. That's what you are going to do. You just remove the key on 5. That's all. Have you seen? I've removed the key for 5. Then I complete the circuit again. Usually, I'm not supposed to be doing this here. Supposing we have a battery rack, it will hold this thing for me. I'm supposed to be opening the key and closing. Are you following? But since I'm not able to do that, I don't have a battery rack to hold my battery together. I'm using this to serve as my key instead. I'm improvising. Are you following? So now I've removed 5. So let's do for 5 and take the reading. What is it going to give us? Can you see? The line is on what?
0.3.
Is 0.3 something with small. So let's just say 0.32. Okay? So we have what? 0.32. So you fix 5 back. The next thing we're doing is for what? 10. Can you see? I remove for 10 and take the reading again. Let's do this reading again. What do we have now? What is this now? Count the 9, then you multiply by 0.06. We have 1, 2, 3, 4, right? Yes. Now 4 times 0.06. What do we have? 0.06 times 4. What do we have?
0.24.
Good. So we have our reading to what? 0.24. Are you here? So the next thing we'll do now is for 15. Can you see? If you look at the resistance box, there's no 15. Okay? But we can find 15 by saying 5 plus 10 is equal to 15. Are you following? So we'll remove 5 and remove 10 to get 15. Then we'll connect the circuit again. Okay, so let's connect the circuit and get our reading. What do we have? What is on what line now?
3.
1, 2. It's on 3 on the dot.
Yes.
Okay. 3 times what? 0.06. What do we have? What do we have?
0.18.
So we have 0.18. This is what we have as our reading, right? Okay. So now the next thing we'll do is what? 20. We'll return this one now. We have 20 here. So we'll remove the key on 20. Can you see? Yes. Then we'll complete the circuit again and take the what? Current reading on what? The ammeter. So let's do this. Let's connect it and then take our reading. Where is it now? The line, the indicator is on what line?
0.2.
Is on 2, line 2. So we have 2 times what? 0.06. Are you following? So what is the reading? Multiply and give me what is the value. We have what? 0.1 what? 2. Okay, so now from the question now they say we should find the I inverse. To do this, we have 1 divided by 0.60. Punch your calculator and give me the value. What do we have? We have what? 1.6. So you have to do this in 3 DPs. 7, right? 1 divided by 0.60. Now the next one now, 1 divided by 0.32. What do we have?
3.125.
3.125. Is it approximately?
Yes.
Okay.
3123.
2325. Yes. So now the next one is 1 divided by 0.24. What do we have approximately in 3 DPs? 4.166 what? 7 approximately. So this one now, 1 divided by 0.18. What do we have?
5.556.
Sorry?
5.556.
5 point what? 556 approximately. Now this one, 1 divided by 0.12. What do we have? 8 point what? 333. You can see we have a fine result. You can see as the resistance is increasing, the current is what? Decreasing. You can see it's decreasing. You can see the trend. You can see the experiment is what? Making sense. Okay? So, and that's the end of the experiment. I hope you enjoyed today's experiment. I'm Sibukola Joseph, the physics enthusiast. Bye.